trouble getting up for stream, which has been in the past week or so. This is probably because my alarm is not working. So basically I use this type of alarm right here, and it yeah, it officially does not, I don't know what the thing is. So like I turned it on last night, right? And then at some point in the middle of the night I woke up and I was like, oh, I wonder what time it is. And I looked down at my alarm and it says it's 5 o'clock, and I'm like, what? Why is the alarm not going off? And then I touch it, and then the alarm starts going off. I'm like, well, that's kind of a useless alarm if I have to touch it to make it go off, you know? So I think what I'm gonna have to do is buy some speakers for my computer and get an alarm that works off my computer or something like that. So that's one thing. The next thing I want to point out is that I have a huge headache right now. Probably because I'm just getting over a sinus infection of some sort. So it's kind of a pain in the butt a little bit. Okay, other things. Yesterday I spent a good bit of time trying to get Julia to work. I in the end couldn't get it to work. That was my bad. So today we're trying something else, which is the gift wrapping algorithm, and we will yeah, so it should be a lot of fun. I'm excited for this one, but we'll see how it goes. I think because I'm not going to be able to do what I intended to do, because I'm not going to be able to get Julia GPU working. I just kind of gave up on it last night. There's too much to do. So I think what I'm going to end up doing is I'm going to end up just kind of doing some small scale simulations, or else getting started on the new graphics thing that I wanted to try working on. Now, in terms of the graphics, there are a number of things. Hey, Jessica. Yes, I can rest a little bit, I suppose. But the thing is, I missed all last week, and I kind of feel bad for missing stream. So we'll see how that goes. I can totally, I don't know. On the one hand, I think it's Wednesday morning, my time. Yeah, we'll see how it goes. But let me think. The other thing I want to point out is that we have, okay, a couple things here. So first of all, the graphics that I've been writing up to this point have all been done in Cairo. Now, Cairo is a pretty nice language. Here, let me just go over here and look up Cairo graphics. It's nice. It works for what we need it to do. In fact, I really like using Cairo. It's exactly what I wanted. So let me go to your... So this is what I've been using. However, I recently found one that's called Skia instead of Cairo. And Skia seems to be faster than Cairo. And I don't know. I would like to give it a shot, just to see if we can draw some stuff with it. Basically, the idea is that, well, you know, if I can get something to be drawn in a faster language that is still somewhat developed, Skia is way more developed, or not more developed. Cairo development has stopped as of recently. Meanwhile, Skia has, I think, continued, because it's being used for things like Chromium and Firefox and things like that. So I know that there are companies behind it, and I know that we can probably use it for a number of different things. So I'm kind of sort of looking forward to that, and we'll see how that goes. Now, the other thing too is, in order to do my next application, I need a couple of different things. I need the ability to create a GUI that can output a video. So that's a little bit of a pain. I don't know exactly how to do that. I thought maybe GTK, because I like GTK. It's relatively easy to use when compared to Qt, but I don't know exactly whether it will be fast enough or not. So I did a couple of things last night. One thing I did is let me see the projects tests. Then I think it was GTK Cairo, yep. And let me just run dash test. I did a quick animation just of like a box moving. And this is an example animation I found somewhere, just to make sure we can do animation with GTK and Cairo. It works exactly as I would have liked, so that's nice. And it just kind of repeats itself. The other thing too is, I think, let me go over here. Let me see if I can actually do something. Let me go to plus, and let me see, window capture, I suppose. Yep, window capture, add existing. Well, maybe not. Okay. Oh, here's what I want. So let me see, what do I have? I want to do test. Okay, so I don't think it actually works very well with test. Okay, cancel. Oh, what did I just do? Remove that guy. Yes. Okay. So I don't know if it actually works that well with GTK apps. I need to figure that one out. But even if it doesn't, I think all of you guys can see this, right? So let me just bring this over a couple desktops. Yeah, you guys can all see that. So worst comes to worst, I can actually just put this down here. and just, you know, have the application running on the side. I kind of like that because it allows me to see what you guys see, and that's kind of nice. Okay, so let me go ahead and close that. Okay, so that's one thing. I haven't quite figured out the best way to do that. We could use Qt also, and Qt is fine, but I don't know. I have trouble using Qt because there's a whole bunch of weird things here. GTK is just C, or you can use it with C++. Meanwhile, Qt has a lot of additional things there that I don't exactly know how to use. Now, I also want to try Skia, and we'll see how that goes. I haven't quite figured out the best way to do that. Okay, so let me get some water, and then we'll go ahead and get started with the gift wrapping algorithm. So, lots of things here and there. Basically, if I want to do some more visualizations, which I really do want to do, in fact, I have a friend of mine who promised that we would kind of go through and learn animations together. So I'm hoping that that turns out well. Because basically my problem isn't exactly that I don't understand how to do the animations, right? Because in some sense I think I can do the animations. It's that I don't really know how to make the animations look good, you know? Like, there are all these animators on YouTube who have, you know, millions of subscribers or whatever, and it's like, you know, they have some good animations, but the trick is making it aesthetically pleasing, and I'd really like to make my videos on YouTube as aesthetically pleasing as possible, so I think this is something I want to try. The other thing is, I would really like to start working on some computational creativity stuff, so let me just look that one up real quick. Computational, oh, one second. Creativity misspelled, but that's okay. Computational creativity, here it is. And I really want to give that a shot. Hey, Gastorn. Oh, by the way, I love Twitch. Jessica Way, hey too. Okay. So let me see. Construct a program computer. Yeah, so that's the thing. I want to try this out. You know, I want to see if we could do machine learning to kind of, I don't know, teach a program art, things like this. I want to just kind of give it a shot. Because there's some cool stuff in here, like conceptual blending. I don't know what that means. Apparently it's Mark Turner and Giles Fauconnier. Sorry, I'm bad at names. Let's see. But anyway, there's some cool stuff here, and I kind of wanted to try it out. And I figure, hey, if we have a good library that allows us to draw things, maybe we have the ability to do more complicated art and things like this. So I wanted to give it a shot. We'll see how we go from there. So let me go ahead and open up a new journal, and let's get started. So, I realize I'm a little bit late. I apologize for that. But today we're going to work on something, hopefully to get you guys in a little bit of a Christmas mood, and that's going to be the gift wrapping algorithm. I think also called the Jarvis algorithm. I think Jarvis... Let me Google Jarvis real quick. Isn't that the AI on Iron Man? Jarvis, let me see. Yes, that is the AI on Iron Man. Let me make sure I did this right. Yeah, it is Jarvis. Okay. The idea here is that we have some sort of gift. I'm going to draw the gift as a large smiley face. Okay, and we want to wrap this gift. Now, here's the thing. What we need to do then is we need to take basically an outline of this object, okay, something like this, and we need to connect all of these points with lines. Now in principle, you guys know this isn't quite how gift wrapping works, so let's take a look at it in another way, which is totally even more like how gift wrapping works. So let me draw a random distribution of points. Okay, now this random distribution of points is, I don't know, something like this, okay? What I want to do is I want to find the convex hull of these points. All that means is I want to find the very outer points. So what I do first is I sort and find the leftmost point. Then what I do is I search through all of the other points until I find this point here, okay? And by find this point here, I basically mean we do a search and replace, and we find that point. And then we go again, and then we go again, and then we go again, and then we go again. And every time we find a new point, what we're doing here is we're searching through all the other points. So at this point, we're searching through here and here, and here and here and here, so on and so forth. So it's not exactly the fastest algorithm, but it is the easiest algorithm to implement. If we want to, we can implement more complicated convex hull algorithms later, but again, This is something I just wanted to try because, again, gift wrapping algorithm, and I did want to kind of look into convex hull stuff. But yeah, this is the most intuitive convex hull algorithm of them all. And it doesn't really get that much faster than this one, you know? We go from this one being, I think, n log n, to the next one being n log h, which is the size of the hull. So the other fastest one is a little bit faster, or a good bit faster, because the hull is the outside. But in the end, all we're doing here is just taking individual points, searching through the space to find all the other points, and then drawing a line. And that's about it. So, yeah. I kind of wanted to give this a shot, see what it looks like. Sorry about that. And, you know, I was also thinking about maybe getting some more videos out in December than I was able to get out in November, because I just wasn't able to get any videos out in November. Sorry about that. I tried, but I just couldn't. So, this is something that would be super easy to draw, especially with the libraries we already have, and just kind of going from there. So, I kind of wanted to give this a shot, maybe with Skia, maybe giving it a shot also with Cairo, and seeing what the difference is between the two, you know? So, we'll kind of mess around with things, but this one should be relatively straightforward to work with. So let's pop over here, pop that over there, and now I will be right back. Again, I'm still a little bit sick, and I'll be back in just a second. Hey Edge, 1 second, I'll be back in just a second. Okay, I'm back. Sorry about that. Yeah, so gift wrapping isn't... I remember doing gift wrapping in real life. Actually, every single Christmas. Every single Christmas. Back in the US. Well, not Christmas, but usually birthdays. Monotone scan. I actually don't know about that one. The other one I know of is the Chan algorithm. So, like, let me see. Gift wrapping algorithm. This one mentions the Chan's algorithm here. But monotone scan. Monotone scan? Again, guys, this is going to be super simple. I find that when I'm learning things for the first time, it's easier for me to understand... Yeah, it's easier for me to understand the... how do I put this? Easier for me to understand easier algorithms. And then I can kind of move from there. Again, guys, I apologize for kind of popping in and out of stream. So, what am I going to do next? Oh, also, in case you did not hear me at the very start of stream, my alarm doesn't work. This is still baffling me, like boggling my mind. My alarm actually has not probably been turning on for the past week, and that's probably why I haven't been able to get up on time. So I guess I'm just going to steal some speakers from work. I don't know, I haven't quite figured that one out. I don't have any speakers on my computer for obvious reasons. I mean, what's the point in having speakers, you know? Like, all they do is make noise, and all making noise does is wake up your roommates. So it's like, no real reason to do it. Okay, what else do I want to try? Yes, that's about it. So let's go ahead and open up our directory. What am I doing? CD projects, Simuleos, and now let's go ahead and make a new directory, and it's going to be called gift wrapping. Sure, well, let's do it. CD gift wrapping. Okay, let's do the same thing over here. CD projects, Simuleos, and gift wrapping. Okay, so what I'm going to do is I'm actually going to do this in C++. I realize some people might not like that, but hey, who cares? I like C++. So let's go ahead and do jarvis.cpp. So let's go into VI. 1 second. Jarvis. 1 second. .cpp. And let's go from there. Jarvis.cpp. I mean, there aren't any real big matrix multiplications or anything like that. Really, I end up... 1 second. Oh, cool. Computational art. Love that. 1 second. Let me go ahead and XX here. There. Let's take a look at this. Oh, for some reason it only copies medium.com. So let's do... that's okay. What do we have? A neural algorithm for artistic style. yeah, man, like this stuff is so cool. Like in principle, right? You can do this with an entire like video. You could put an entire video into this type of format, you know, and that's kind of neat. Like I like that idea that you can take any image and you can like reconstruct it into another person's style. It's super cool. Like this is, I know it's not going to replace an artist, you know, like that's not the idea here. But for me, I could never hope to, you know, really, I don't know, I can't do that great, or I'm not that great of an artist myself. Like I don't trust my hands. I do, however, trust code. I trust my ability to put things into place via you know, Cairo and stuff like that. I trust way more than I trust my own hands. So in some sense, I really think that for me, trying to go this route will be easier, I think, in the end, than trying to go the route of actually learning to paint and stuff. Because I mean, again, my friend that I'm going to be learning animations with is an artist, and she spent years and years and years perfecting her craft, and I could never hope to do that. You probably need to use a library for that. Oh, that's no fun then. I mean, like, I don't know. No, it's fine. It's fine. We'll see. So let's pop down here and let's do 1 second. Purpose to implement a simple gift wrapping convex hull algorithm that and let's do I need anything else here? Let's just go ahead and just say, because that's all this is, and it's gonna be Jarvis, and that should be okay. Hey Slayerdarth, how are you? So let's pop down here and let's go over here. So again, guys, I kind of pop between C++ and Julia at this point, especially on my stream. The one thing that I you know, basically it depends on how I'm feeling that morning. But in the end, it's basically just, do I need a vector library? If I don't really need a vector library, I'm using Gustron's favorite CMS. Wait, what is CMS again? Sorry about that. WordPress? CMS, what does that stand for? Yeah, I could imagine that. But it's no fun if you just use a library, you know? Like, that's a content management system. WordPress is a content management system? Huh. Things you know, or things you learn. Okay, so what I'm going to do, I'm going to go ahead and create a function to, what do I want to do here? I'm going to need a function to, I suppose, initialize everything, right? So we need to initialize random points. So let's say initialize random points. Okay, so it's going to be function. And what do we want? Oh, I'm already doing Julia. Crappy blogging pattern into crappy management system. Oh, content management system. Bah. Yeah, so I think you're right, Gustron. It's just by providing, like, by going from something that I can do to something that I need other people to do for me, it goes from something that I can do on stream to something I'm not going to be able to do on stream. So that's the thing, you know? Yeah, I need to kind of think about that. Let me see. I don't like doing things on stream that are just like pre-built libraries, you know, that other people can use. And I realize I may have done this before, but for the most part, I kind of like to write my own code for this kind of stuff. So if it's not something that I can implement, then it's not something I can implement, and we go from there. I was talking to you online earlier the other day. Okay, good. That's always good. Your surname is German? Oh, that wasn't very much talking. You just found my Twitter. Yeah, so my surname is German. That's fine. But it's because I live... I don't know. There isn't really a reason for this. My family used to be German. And then they moved to the US. And I'm now the least German person possible. Like, well, not the least German. I've got some, I suppose, German traits in my, you know... I'm like 50% German in a way. But yeah, they moved over here around the time of World War II, and at the time, they didn't allow my grandparents to learn German because they were kind of growing up, and they knew that if my grandparents knew German and also had a German surname, they would be kind of ostracized a little bit. And so my grandparents didn't learn German, and I didn't learn German. And my parents didn't learn German. So basically, like, none of us in our family know German. Yeah, you're right. So I'm still 50% German. But from the other side of my family, I've got, I don't know, I guess French, Norwegian, a bunch of little things here and there. But for the most part, I'm mostly the German traits up here in terms of what I physically look like. But again, I'm clearly American. I'm not from anywhere else. So what am I going to do here? Let's go ahead and also create a class, or a struct, to hold all types of, hold, I guess, simulation data. Okay, so I guess at minimum, this needs to be, I learned German. According to my LinkedIn, I have a work level proficiency in German Kappa. Oh, so for some reason I read the German Kappa as together. Yeah, for some reason, every time I hear people speaking German, everyone says they sound really, really angry, and it's like, well, they don't really sound that angry, but I don't know. So let's do struct, and what do I want here? I guess we're gonna call this parameters. I don't know, yeah, we'll call it parameters. Sure, let's go with that. Okay, what do we want in here? Well, we have a couple of different things. Looks like I'm the only non-German living in Germany now. No, I'm sure there's a lot of non-Germans living in Germany. Again, I have not been to Germany before. Novelis, it's all bratwurst. Okay. Hey, Novelis and Bobson, thanks for coming in. So let's see. Struct parameters. What do I want in here? I guess I want a double. Let's read in vector. Include vector. Yeah, sure. Let's do this. So let's do vector of double. And let's do, what do we need? In the end, I think what I'm going to do, why are your sausages so bad? I hear they're the worst. You should stop by sometime. Yeah. We'll see. So vector double. And what do I want here? I want a couple different guys. So I want the whole. And I also want one more vector, which is going to be, they call it S in the algorithm that I'm looking at right now. But I guess this is going to be called the distribution. Or something like that. What should I call it? Slayer, your Christmas puns are already too much. No need to branch out. Okay, so what do we have here? Whole, distribution. What else do I need here? Come on. Oh, holy crap. I am super scattered today. I never even finished my previous story that I was talking about in terms of the gift wrapping stuff. So yeah, every time someone has a birthday, I used to always wrap presents in like the meanest way possible, you know, just because it was kind of fun. Like it was a little trick to figure out how to open up the gift, you know? So like, let's see, we used to, you know, obviously the whole hiding a gift somewhere and like having them open up a huge box and not having the gift in there and having to go on a scavenger hunt. That was one of them. This is when I was younger, you know, and it was still kind of fun to do this kind of stuff. The other one I did that I was really proud of. Oh gosh, I was super proud of this one. I took a box and I filled it with rocks. And at the very bottom, I put this cardboard, like I gave them like a game or something like that. So I put this kind of cardboard bottom so that people would not expect anything. You know, like they wouldn't expect that there was anything in the box. And then after they open up the box, they see just a whole bunch of rocks. They pour out all the rocks and still all they see is rocks. And they look down there and they're like, you know, there's tape keeping down the very bottom. So people don't usually think about it. But if you opened it up, there would be the game underneath. So like, I don't know, I was very proud of that one because like, I really got my brother with that one because like he opened up all the presents, he opened it up and he couldn't find the gift. And I was like, yeah, that was like peace de resistance or whatever. Okay, so hill, distribution, what do I want to call these? I guess we'll call them points. Screw it. That's what we're calling it. I'm not worrying about this any longer. So, to initialize, what do we need? Well, we need to initialize a couple different guys, so let's go ahead and initialize parameters. What am I doing? Vector. Let's do parameter. What happened there? Parameter. And we're going to call this init. And they're not going to need anything. Actually, yeah, we can read it something in here. So let's go ahead and put a semicolon there. And what do we need to read in here? Let's go ahead and read in, I don't know, let's read in int resolution. Let's say number. Good. So this will be the number of individuals that we need. So that's the function to initialize everything. And now we need a separate function to wrap the points with a hole. So now we're going to say, I guess it can be a void, right? And maybe, no, maybe it should return. Yeah, it should definitely return the parameter too, still. Or I can just do it that way, void, and then we're going to say, what do I want here? Void, and let's call it gift wrap. And let's read in parameter. And I guess we'll call it par for now. Okay, something like this. These are all the functions we're going to need. It's not going to be too much more complicated than this. Now, if we do some visualization, it can get quite complicated. So let's just kind of go from there. And that was a Christmas tree pun, Gus Run. By the way, guys, I have been thinking. I've been thinking about doing a whole bunch of different. How do I put this? I'm thinking about doing a whole bunch of different Christmas simulations, kind of like starting with the gift wrapping algorithm and kind of going from there. And actually, all these simulations I could put up on my YouTube channel because, like, hey, it's kind of in the Christmas spirit. But I don't know. We'll see how that goes. I haven't quite decided the best way to do that. Anyway, so let's go ahead and initialize these functions. So in the end, main is just going to have a couple different functions in it. It's going to be, let's say parameter. Par is going to be equal to init of, let's just initialize 100 points. And then down here, we're going to say gift wrap. And we're going to gift wrap par. There we go. That's going to be all we need here. So let's pop down here. Let's go ahead and create the functions. So it's going to be parameter init. And we need int num. And we also need down here void gift wrap. And again, guys, if every time I start a new file, I think a lot of people question my choice to do it this way, but basically all I'm doing here is let's do it this way. I like to have all of the functions kind of described up there in case I want to put it into a header file, and then I like to have them actually like in depth under main. I don't know why I got into this habit. I think it was because of, I don't know, I have no idea why, but it kind of makes things a little bit easier for me to read because I know where main is and we can kind of go from there. So let me go ahead and comment this guy in. I also always parse the file up in this way. And yeah, I know it might look a little bit ugly, but this is what I always do. So I always kind of have an additional guy here for main. Sorry. And then I also have an additional note for subroutines down here. So let's go down here. This is just so I can easily find things in the file. Now I realize that, yeah, you don't necessarily have to do this. It's just kind of what I do to make it a little bit easier for me to find things. Okay. One last thing I wanted to point out is we already have a kind of graphics library that I was working on before, which was the subroutine library for the subroutine webcomic that never actually ended up happening, but I'd really like to make it a thing at some point. I just kind of ran out of time. So let's go ahead and create function to initialize random points. Pop down here, function to wrap all points with a hole. Okay. So let's go ahead and DD there and open these guys up. Pop this there. Down here at the end, pop this there. And let's go ahead and remove the semicolon. Okay, so now we have everything we need. Let's go ahead and return parameters. So first we need to initialize the parameter function. So we're going to say, sorry about that, parameter par, return par. Okay, so now what we have to do is randomly set these guys up. So one thing that I always forget how to do in C++, I don't know why, but I always forget what to do from there. So let's go ahead and do include. And what I want to include, I want to include random. Okay, so let's go ahead and keep going from there. So what I want to do is I want to go ahead and create a random distribution between, I suppose, 0 and 1. It doesn't really matter where we put all these guys, so I guess 0 and 1 is fine. And what we need to do is we need to, I suppose, have these guys all have an X and Y all these guys need an X and Y location, right? Because gift wrapping, I think, is inherently at least 2D, but it could also be 3D. And I think we'll kind of go from there. So with parameter par, we need to return par. Now, what do we need to do inside of here? So each of these guys should have a position. So let's go ahead and also create a struct for the position. Let's go up here. Struct. And we could just read in our vector library, but I don't think there's that much we really need here. So let's just go and do struct. Position. And in here, we're just going to have a double X. X and Y. There we go. That should do it. Let's pop down here and let's change this to position. Okay. Let's go ahead and add in a semicolon there. And let's keep going from here. So now we have to randomly initialize all these guys. So we need two random numbers, one for X and one for Y. So what we're going to do is we're going to say for I equals 0, I less than num, I plus plus. Okay, and so first let's go ahead and initialize our character here. So what we need to do is go ahead and initialize our vector. That's going to be the, where is it? Whole, no, points. That's what we want. So what we need to do here, and forgive me because my C++ syntax is now failing because I've been using Julia so much for the past few days, but what we need to do is set points. Oh gosh, I need to malloc it. How do I malloc it? I know I've done this before. Let me just go ahead and look at some old code. So let me just do a quick ls ... And what do we have here? Genetic algorithms. What was the last thing I did in C++? Have I really been using Julia for that long? Because, like, I guess because I ended up having to take a week off and stuff, I've been using Julia for a good past couple weeks. It's a lot of time. So let's see. Viral video, tunneling, visualization, test, igloo. Where did I put... What's the last thing I worked on? Color quantization? No way. Surely there was something else I worked on in C++ before then. Optimal control, OpenGL, machine learning. Archive ants. What? Where was the last thing I worked in C++? FFT, geometrical optics. Let me think. I know I did the viral video stuff. So let me go ahead and take a look at that. So let's go into vi.viral video. And what do I want here? I suppose I want viral video.cpp. Let's see. So I know I have a random thing here. So let's go ahead and look for random. This is useful. We're going to need this anyway. So let's go ahead and grab this guy. Again, I always forget how to initialize random stuff. Let's see. BNU Gaming, do you have a hotkey in your configuration to add a new line? Or do you just insert mode and enter key? No, I'm using VI. So what I do is I press the O button to create a new line. I press DD to remove a new line. Capital O to create a new line above. VI is super useful for a number of different guys. It's not malloc, it's reserve. That's what I need to do. I always forget how to reserve something. That I just didn't remember the keyword because I haven't used vectors in a while. I use because I do a lot of CUDA stuff at work. I end up using just a regular C-style arrays most frequently. So let's see, what do I want here? I want to do, let's go ahead and create the random device too, so while we're here. So creating device. And let's go ahead and pop in here. So let's see if I can, I always forget. Static, std, random, device, rd. Pop down here, and we're gonna say static. And then we're gonna use the Merlin twister. So it's gonna be std, Merlin twister, a Mercine twister. I always get that freaking, oh my gosh. 19937 gen of rd here. And then finally we say std uniform int distribution, double distribution, real distribution. That's probably it. Real distribution of double. I was just unsure of the hotkey. I only really started using Vim like 3 months ago. Yeah, so there's a good number of hotkeys. Let me go over here and let's see. What are we going to call them? How about key bindings? Vim cheat sheet. Yeah, something like that. Yeah, that's true. That's not the one I was looking for. Let me just go to images. This is the one I actually have at my desk. So I guess let's view the image. So I think it's quite useful, but maybe other people don't. So what do we go? Uniform real distribution double. Okay, that should be okay. And the distribution is going to be called, I guess, position distribution. Let's do position distribution. Okay, and it's going to be between 0 and 1, just because this is easy. Okay, so now let's go ahead and create the parameter par. And so now we're going to say par dot Vorak layout won't be that widely applicable. AOE. Oh yeah, I didn't even realize that the keys were in the wrong position. Oops. Yeah, 1 second. This wasn't the one I used. Maybe it's this one? Yeah, it's this one. Sorry about that. Wrong layout. Okay. Maybe they're in the wrong position. I don't know. Reserve. And I want to reserve num. And that should be okay. I think. Unless I've totally forgotten C++ syntax. Reserve was the keyword I was looking for, I think. So what do we have? So we have the position distribution. I guess we're good to just go from here. So now what we do. But thanks, I guess I learned something. I haven't had time to actually sit down and learn it. So I might just print off the sheet and put it by my desk. Good idea. Yeah, so the truth is that, what do I want to say here? Vim bindings aren't exactly intuitive to get at start, but then after you learn them, it's kind of like you don't ever want to use anything else, you know? At least that was my case. Because it ended up being that, like, once I learned how to use VI, it was like, oh my gosh, why would I ever use any other text editor? Like, this is clearly superior to just about everything I could ever want, or ever use in another, like, this is the best text editor, basically. That was my opinion. It still is my opinion. I really like VI. It's super easy to write in once you get used to it. Okay, so now we're going to go through all of them, and we're going to initialize their positions. So I want to say par dot, and I guess I want to say, oh, I screwed up here. Par dot reserve was not right. I want par dot points. Hopefully this will work. So let's say par dot points of I dot x is going to be equal to, I guess, position distribution of the generator. And we're going to do the same for y. So let's go ahead and do our y. I don't know if this is actually going to run, so let's do G++. And what do I want here? Drivers.cpp, and I guess I'm going to run std C++. Equals C++11. Vector is not declared. Of course not. So every time we do vector, we're going to have to put an std in front of it. Next. Oh, it's only used those two places. Okay, good. That means we have a whole bunch of other issues. So, parameters does not name a type. Parameter init. It looks like it does. Struct parameter. Parameter init. What did I do wrong there? Let me go up here and let's see what we have. So it looks like there's a whole bunch of other issues. Vector does not name a type. This is... let's go ahead and clear this. Control L. Let's try it again. I use std a lot. Let me see. Yeah, I like Vim. I've always used Sublime and Atom, but I got tired of them because moving around was so slow. But HJKL keys are so much nicer to use than my cursor. Yeah, so then cursor, yeah. You can also use arrow keys for most standard VI bindings and stuff like that. I actually use arrow keys on my own. Let me see. Yeah, I use std a lot. It's fair enough. So parameter does not name a type. Okay, what's the issue here? We have parameter, struct parameter, parameter init, parameter. Oh, there's an S. Let's just kind of do no S. Okay, and the last thing we need to do, I was not declared in the scope, and let's go ahead and put int I. Thanks, Bobson. Okay, the most important thing that will speed you up a bit, navigating words by forward and back. Yeah, that's fair. Your struct is called parameters. Yep. Thanks, Mr. Fabson. Sorry about that. I don't know what I was thinking. That's totally true. Okay, let's go here, right? Now, let's go ahead and compile it. Good, it compiles. Clear. Bam. Got that one working. And just for good measure, let's go ahead and run the SL command, because everyone does that. Okay, so now what are we going to do? PowerPoints. Why did I do that? Par points, X. So this should be okay then. So now we have all the points positioned. Now what we have to do is find the far left. So now we have to find the far left point. Oh, actually, because we reserved it, I guess what we need to do is we actually have to say par points X. Oh, you know what? Maybe we have to push it back. I may have done this incorrectly. So let's pop down here and let's go ahead and create a point. Let's pop up here and create point temp. Let's go here and let's say temp.x. It's going to be equal to position distribution generator here. Let's do the same for y. And now let's do par dot points dot pushback. Is this what I need to do? Temp. Wait, I gotta think here. When's the last time I did reserve? I have a good Christmas song. Can you can play? Sure. Yeah. Go ahead and send it to me. So let's do reserve. Reserve history. Yep. Okay. So reserve 10, and then in the end we have to do video list.reserve. Where do we do video list? See, is there another reserve? Network.reserve. Network. Yep. So it is pushback. I did that incorrectly. DD. There we go. That should work now. So now what I need to do, let me think. So we can reserve space to make this a little bit faster, but for now, let's just go ahead and create our first hold point. Now the hold point is going to be a little bit more annoying to work with, but that's because the array has to be kind of like dynamically allocated as we go by, because we don't know how big the hole is going to be. We don't know how big the gift wrap on the outside of the gift will be. I read the Twitch description, but didn't say which distro you're using. I'm using Arch Linux right now. Yeah, using Linux, specifically Arch Linux. Oh my gosh, we have the beginner's guide. Oh man, that's so sad. I just realized the beginner's guide is in that link. Oh man. Oh my gosh. Yes, let me go ahead and play this video. Let's go ahead and turn off the music I have right now. I think it's here. Nope. Which terminal is it? That is a good question. Oh, it's this one. There we go. I'm going to go and pause this music and let's see what you linked. Open link. I wish it could be Christmas every day. Okay, so what do we have here? Find the far left position. Oh man, Santa's like rocking it on this one. Oh my gosh. But you changed it to the installation guide. Yeah, I stream Arch as well. Nice to see another person use the same OS. Yeah, I think a lot of people who use Linux actually use Arch. And it's quite interesting, I think. Okay, so let's pop down here. Find the far left point. So I guess what we need to do is sort it according to something. So let's do I guess we have to sort according to X. Oh gosh, everything I hate. So let's do par dot. Hey Gambino. Just answer that question, but I'm using Arch Linux right now. I think the truth is, everyone is slowly converting people to Arch. Like, in the end, it's so nice. Arch is such a nice distribution. But, yeah, the truth is, it's not best for everyone, you know? Let's see, par dot points. I guess dot sort. Do I use a sort over here? I do use a sort. Fantastic. So let's do std sort. Oh my gosh. You skipped my question about coffee. Oh, I'm sorry, I missed that one. But I now really want to get your answer. Sorry for distracting you anyway. I actually do not drink coffee. The answer, the reason is kind of silly. I never got into it, and my sister has heart palpitations sometimes when she drinks coffee, and so I didn't want to screw things up. It is not so bad to create what I have right now, Gambino. It's actually relatively straightforward. All you have to do is download OpenBox and then use a terminal that I don't use called Sakura. The Sakura terminal is relatively fast. So you can install a DE. Yeah, of course. Yeah. Okay, so we want to sort. Guys, forgive me for this. Par dot points. And I want to do dot begin to create the first iterator. Then par dot points dot end. Okay, and now we have to give it the list that we're working with here. Anyway, gotta go. Nice person. Ah, thanks, man. I appreciate it. You mean the Arch Linux ISO? I wouldn't recommend Manjaro. They freeze packages for no reason. Oh, didn't know that. Yeah, so let's see. What do we want? Par.points.end. Okay, so what I want to do now is create. Yeah, I think I can do it this way. Forgive me, guys. I'm really bad with Lambda functions. Server just browsing the screen, but your terminals look awesome. Thanks, Gambino. Oh, yeah, that's another thing. Yeah, so if you want to, we have a Discord server. Feel free to pop on and chat. I have it up actually right now behind my internet browser. Oh, maybe not. Maybe it's over here. But yeah, we have some chat going on. Feel free to pop on. Hope on Discord. Let me get this done. Okay, Lambda function. I hate Lambda functions. I'm really bad with them. So what I want to do is I want to return. And it's going to be par.points dot of I dot x. No. I need to pull out the x. I need to sort them by x. So it should be something like dot x. And then greater than? No, less than. Par dot points dot x. But what I need to do is figure out how to check one versus the other one. Come on, puns are great. Everyone likes a good pun. So let me pop this down to the next line, and let's see. What I need to do is add a parentheses down here at the end, and then a semicolon. Could one of you gents link me to Arch installation? Just do this, and you'll have access to the installation guide. It's kind of a pain to work with because it's not the beginner's guide, but you know, if you have any questions, feel free to hop on Discord, and we can talk about it from there. Okay, so par.points.x. Now I know this is incorrect syntax. Let me go ahead and pop up my music again. Now, what do I want to do? I want to figure out how to work with freaking Lambda functions. Okay. So what I'm going to have to read in then, am I going to have to read in an I? No, I just want to relate. Will this compile? Probably won't. I'm being too hopeful. Oh, it compiled. I must have not written it. Yeah, I didn't write it. Dang it. Okay. I think the song is the highest grossing Christmas song in the UK. You kidding me? Wow, that's crazy. Okay, so I want to... Let me go back and look at that sorting thing again. I'm sorry, guys. I always forget Lambda functions. There's one thing that I just always forget. Ben literally never had to work again. That is crazy. Okay, so we sort everything. A.val. Constant video A. Okay, so I guess in here we read in two different points, A and B. Let me see. Where do we read in A and B? Constant video. Oh, I see. So what we want to do is constant point A and constant point B. Okay, I think I'm getting this. No, I'm getting it wrong. Dagnabbit. The two things that we're going to be comparing are this constant point A and constant point B. Okay? And what we need to do is we want to return... Oh, come on, I can do this. That. I think this is right. So this means we're reading in 2 points, A and B, and then we want to return back A dot points, A dot X, and then B dot X. Something like this. It is OpenBox. So with Linux installations, you download the Linux distribution and then you add on the UI on top of it. And the UI I've chosen, the Windows Manager I've chosen, is the OpenBox Windows Manager. So that's kind of what I decided to do. Let me go ahead and write and quit here. And let's see what happens if I write this and compile it. Okay, point was not declared in the scope. Okay, that's because it's called position. Position here. Let's go down here, constant position. IS. Is desktop environment is what it's called, DE. Sort is not a member of STD. I guess I have to include sort. Let's see what happens. Or does it include algorithms? Maybe algorithms? Have a capture list inside of the lambdas? Or inside of the boxes? I think OpenBox takes quite a long time to load though. What do you mean to load? It takes a while to get set up, that's true. But it's definitely snappy. Like, it doesn't take very long at all to get everything working. Let me pop back here. I thought Unity was a DE. I don't know what you mean by Unity as a DE. DE stands for desktop environment. Let me pop back and check viralvideo.h and let me see what headers I have read in. So algorithm was right. Good. Let's pop over here and let's do. Yeah, I think this should be okay. Yep, thanks, Mr. Fabson. Sorry about that. I really need to get better with Lambda functions in C++. So now let me go ahead and clear here. Let's try compiling it one more time. Error, yes, so I need a semicolon there, and I think that's about it. G++. Okay, so it seems to run. I don't know if it works or not. We'll check that in a bit. In fact, we should probably test that now. Yeah, okay, we'll test it now. So we have a parameter here. Let's just go and output X and Y's for each of these guys. Make sure that they're random distributions between 0 and 1. Oh my gosh, why can I not? There we go, that's what I wanted. So now let's do a quick for, let's do size t, I equals 0, I less than par, dot, points, dot size, and then we're going to do I++. I don't have a DE, it's just a Windows Manager. I mean, in the end, I'm using OpenBox as my DE. OpenBox is a Windows Manager. Yeah, so in the end, you can use OpenBox as your desktop environment in a way. So let's do here. And let's do std cout, and I want to do par dot points. Yeah, this is fine. Of I dot x, new tab, and par dot points. Sorry about that. Of I dot y, new line. Let's go here. G++. Seems to work, and now let's do a dot out. Maybe I should have put a tab in between these two. G++, a dot out. Okay, so it doesn't quite work. We have random for X, but not for Y. Why don't we have it for Y? That's because I haven't defined it for Y. Let's go down here and change this to Y. Now let's do G++, a dot out. Okay, good, that seems to work okay. Is Windows Manager someone who works for Microsoft? Oh, Gustrin, could you make your entire list is set up? I need to recreate Simulus' layout. Actually, so I could give you guys that if you want, but I didn't expect too many people to be interested in my actual layout. Truth be told, I'm using a self-defined version of OpenBox. Like I have a custom theme that I'm using with OpenBox that uses 3 colors. It uses white, black, and 57, 57, 57, I think. Yeah, I think that's what it uses. Maybe it's 77. I know there's a 7 in there somewhere. I have to look at it. But yeah, I did take the time to make this theme myself. I don't know why, because like it's not really that great of a theme, but I like it. It's nice and simple, and then that's all you need. As far as the desktop itself is concerned, I actually do not have anything here. Like, I don't actually have a desktop. I have not installed anything but a desktop background, which I use with Nitrogen. But I don't actually have icons that I can put on the desktop. I don't really like icons on the desktop. I think it's kind of a, I don't know, it doesn't strike me as something that I like to do. But yeah, exactly as Gustorm said, just follow the installation guide and you should be good. Well, yeah, you should be good. Okay, so let's pop down here and let's actually write the gift wrapping function now. Where am I? Okay, so now for the gift wrapping function. We have par here. And what I didn't do is output the whole. So let's also output the whole. How much did I spend on my audio setup? Let's also out here and do std cout. And let me just do par.whole.x and tab and par.whole.y. New tab. New line. And let's pop over here. What am I doing? Write this, go over here. G++. SD vector. Oh, that's because I have to do whole of 0. There we go, and put it in over here too. Okay, so I was looking at some Linux tutorial videos. So my audio setup. Currently I have a couple of different guys here. I have the Focusrite Scarlett Solo, which is what I'm using as a preamp. I have a dynamic SM58 microphone. So it's kind of expensive, some of this stuff. So let me see. I don't really know. I guess if we just go to Amazon.com, I can give you the two things that I have. The main thing is the SM58. If this will load, give it a second. Here we are. So SM58. This guy. So I guess feel free to look at it. I did spend about, I think, $200 on this. So the SM58 is this guy. That's the one I'm using. I have an on-off switch so that I can turn you guys off or turn it off if I need to. And the other thing is the Scarlett Solo? Something like this. Yeah, this is it. I bought them both when they were on sale. So it was relatively straightforward to buy. And then from there, that's all you need. I have an additional crane or something like that. I don't know what it's called, but it's like a desktop mount of some sort. So that there's like an arm from my desk to where the microphone actually is. So that's quite useful. But outside of that, that's about all I have. So let me go ahead and close that. I can't believe that was the #1 grossing Christmas song. Also, guys, I'll be back in just a second again. Sorry about that. Again, still a little bit sick. 1 second. Okay, I'm back. Sorry about that. Yeah, so the Scarlett Solo is what I'm using to connect to my PC, and the dynamic microphone is what I'm using so that you guys can actually hear me speak. Then from the inside, I'm using jack. So I'm using the jack audio interface so that I can interface with OBS. So that's kind of how I do it. I also have CAF that I'm using to do for a compressor, because I found that the Scarlett Solo plus SM58 is a little bit quiet. I would like it to be much louder. So just want to point out that yeah, so I just want to point out that it is a little bit quiet on my end. I don't know why. So maybe you want to get a better preamp or something like that, or a different microphone. You could also just get, you know, one of the standard microphones, which would be like the Blue Yeti or something like that. Yeah, the Blue Yeti works. This is what most people use, and I think you can use it just fine with your system. So something like this would also work. Yeah. Okay. If it'll load. I think this is what I want. Yeah, so this is what most people use, I think. And it's cheaper than what I did by a good bit. So in some sense, maybe you should just use this. But that's how it goes. I was giving you a chance, man. I was totally giving you a chance. Okay, so let's go ahead and work on the gift wrapping function. What do we need to do here? Well, we already have the parameter, right? So now what we need to do is expand the hole. So we need to basically continually push back the hole. And this is where the actual gift wrapping algorithm comes in. But unfortunately, it's not very long. So this should be okay. You know my OS, man. So what am I going to do? Let's go ahead. We already have the initial point on the hole. So let's kind of go from here. So what I want to do is kind of go through here and expand the hole. I mean, I don't know, man. I'm sorry. Okay, but I don't know. I'm sorry. Yeah, we kind of knew it was Frank. Okay, so let's go here. And let's say, what do I want to say? So the hole actually could be, instead of a list of points, it could be a list of integers. And I think that might be the better way to do this. So let's pop up here. And let me just go ahead and change the hole into an std vector of integers. And let's call this hole. Okay, so these are going to be integers that we can use for the points. Does that make sense? So like, instead of... Wait, let me think. I have to think about the best way to do this. Gustorn, how do I ignore him? Let me think. I'm trying to think of the best way to do this. We can have the hole as a list of points, again, and that's okay. Or we could have the hole as a list of integers to read into the points. Which one's better? I don't know. I think yeah, I think this is okay. So how about this? I'm going to say hole up here and then points down there. And then let me just go ahead and create a very quick distance function. So let me go ahead and do that in here. So we're going to say double distance function between, one second, points. Okay. And we're going to say, I don't know, / ignore Simuleos. Feel free to do so. Okay, so we're going to say double and we're going to say distance. And what we need to do is read in 2 different points. So we're going to say position A, I suppose, and position B. Read this in here, and we're going to return square root of, and I suppose it's going to be a.x minus b.x times a.x minus b.x. And let's go ahead and put that in parentheses. And then what we're going to do is we are going to subtract out, plus. It's going to be basically the same thing, but for y's. So it's going to be a.y minus b.y times a.y minus b.y. I could have used power too. Whatever. Doesn't matter. Let's go ahead and add a semicolon down there. So the reason I created a distance function is because in order to know that you're properly gift wrapped, what you need to do is you need to basically create the hole and then return back to that point. So we need to just keep kind of going until we find the hole again. Okay? And let's go and do it. So what we're going to say is while distance between, what do I want to say? I guess what I want to say is a couple different positions here. And we're going to say temp. 1 second. On IRSSA, Gustorn's name has an @ in the name. Oh, I didn't know that. His name doesn't have an @ in his name here. Maybe. Yeah, could be because he's a moderator. So let's say position hole. And then I guess hole. Yeah, let's just say hole. That should be good. Yeah, that'll do it. Okay. So while distance between... Oh, nope, that's not going to do it. That's a bad name. Hole point, maybe. hole position, current hole point. Whatever, I'm spending too long on that. Current hole. And the other position I want is par dot hole of 0, which should already be initialized. And then we do distance here is greater than 0. Just some random threshold. So let's go ahead and read in threshold. Yeah, that should do it. And pop down here. Okay, so now we have to go up here and define threshold. Double. 1 second. Threshold. If I can spell threshold, that would be fantastic. Threshold equals 0.001, just to be safe. And now we're going to say, what do I want here? So it must be room moderators. Okay, so let's pop down here. While threshold. Now I also need an int I equals 0. Okay, good. Now what do we need to do from here? Well... Hey, Frank. Let's see. So what do I need to do here? Distribution, current hole, parameter hole. Yep. Where are the thresholds? Okay, so what we need to do is check to make sure. Just do distro. That's it, and then you'll have the installation guide down there. To be fair, Frank, the installation guide is actually quite hard to go through. So they used to have something known as a beginner's guide, which might be a little bit more up your alley. And I say that not meaning that you're a beginner. To dimensional rifting? What? Arch. But everyone used to use the beginner's guide. Like, it's literally the most used thing. But let me pop down here, and let me see. So beginner's guide. This document will give you through Arch Linux installation, video side. This, I think, is the old school beginner's guide. So feel free to take a look at it, because it's a little bit easier to go through than the installation guide. Actually, it's a lot easier to go through. It's a little bit longer, but it's definitely worth a read if you're wanting to install Arch. I think... even if some of it might be a little bit outdated now, it's still very easy to use in comparison. So just kind of pointing that out. It used to be that was on the wiki, but now it's not. Okay, so now we're actually moving on to the gift wrapping algorithm. Let's pop down here. Let's see what we got. For distance, current hole, par.hole. So let's go ahead and set current hole equals par.hole 0. So it is the initial point to start. Okay. Oh, maybe we should do that in here. 1 second. So let's do, and let's also create this an int instead of an in. Oh my gosh, what am I doing? So now we're going to say, if I equals 0. I just can't do it. I cannot do it today. Everything is just, I'm screwing up on syntax and everything. Pop down here. And we're going to define current hole as equal to, what do I want here? Par.hole of 0. Okay. Heading out for now. See you around SlayerJar. Thanks for coming in. Keep crashing my browser. Wait, what are you doing, man? That you keep crashing your browser. Oh, we didn't get nearly as far as I was hoping today. We might have to make this a 2-day thing. It's okay. It's probably going to have to be a 2-day thing anyway. But I'm trying to do some super complicated automation. Automation of your bot? No. Yes? I don't know. Okay, so what we're going to say is... 1 second. We're going to have to keep pushing back the whole point, right? So we're going to have to keep pushing back that. And since we're on I equals 0, we go ahead and set it equal to the whole point there. Okay? Now what we say is for... let's do I int, let's do int j, 0, j less than, let's do par.points, dot size, j++. Okay, so here we have that. I'm trying to do launch website and return the URL portion. Oh, I see. So now what we need to say, if the endpoint, let me see. So we're going to say, 1 second, I wrote this down, but I'm not sure I fully understand what I wrote down. So let me pop over here real quick and let's go to the gift wrapping algorithm here. Here's what it says. Point on whole is the leftmost point in S, okay? We say I equals 0, and then we do this loop for a good bit of time. So we say Pi is going to be the point on the whole. Good. We say the endpoint is S0, okay? For J from 1 to S, okay? If the endpoint equals the point on the whole, or, let me see, S of J is on the left of the line Pi to the endpoint. One second, I gotta think here. If endpoint equals point on whole, or S of J is on the left of the line from P to I to endpoint. Wait. Ah, crap. I understood this last night, and then I totally forgot what I was doing. Endpoint equals Sj. I plus 1, and point on whole equals endpoint. Okay, that's easy enough. Okay, so endpoint is going to be S0. Okay, where S of 0 will be, I guess, the first point in S. Sorry about that. And S is your distribution of points. Okay, so Pi is going to be your point on the whole, and Si is going to be a random point in space. Okay, so now what do we want? We say for J from 1 to S, Y1, S0. So you're excluding the point that S actually is, but the question is, do we resort S every time? If endpoint equals point on whole, 1 second, P of I is point on whole. Oh, I see, so point on whole equals endpoint. Okay, so that's the last point we were on then. Okay, or if S of J is on the left of line. What does this mean? If S of J is on the left of line from Pi to endpoint. Oh, I see. So here's what we're doing. So let's go ahead and we're constantly looking. Wait, how do you go back around? 1 second. S of J is on the left of line from Pi to endpoint. Wait, I gotta think here. So let's pop over here and let's see what we got. So new page before. Okay, so we have this random distribution of points, right? So we have all these points in here. Okay, and what we want to do is trace out the very last elements. I'm trying to automate the process of generating them and storing them. It requires a GUI-based browser to do the interaction, so I have to automate that interaction. Copying and pasting the data to determine how the heck I want to deal with it and be able to keep it secure. I see. I'm sorry. Oh, also, I have to point this out. One other thing that has been really irking me lately. YouTube changed something on their end that basically makes it so, how do I put this? I can no longer edit my videos on YouTube. By that I mean, I used to, at the start of, like, at the end of every day, or at the end of every stream, I would upload my video to YouTube, I'd go work out. When I come back, I would then edit my video on YouTube to remove the first 5 minutes, where basically it's just, stream is about to start. You know, like removing removing that. However, I cannot find the ability to do that anymore on YouTube. So I don't know how to do that, which is kind of a pain. Anyway, here's what we're doing. So first of all, we select a point here. So point on whole is going to be the leftmost point. So it's going to be this point right here. Then what we do is we search through all the other points. And I think what we do is we calculate the angle between all of these points, right? And we say, okay, well, we want, 1 second, I gotta look at this again. Yeah, so we want this angle. So right now we're gonna have to draw a plane here, but we want this angle here to be as great as it can be, I think. Oh, I guess it's measured from here. Okay. So now we have a new line drawn from here to here, and then we want this angle to be as great as it can be. From here to here, this angle, here to here, this angle, here to here, that angle. Now let me think, if we do angle-wise, then we have to measure measure the angle between basically the 3 points. No, this doesn't work at all. Because look at this. If the angle has to be as large as possible, maybe the angle has to be as small as possible. Yeah, I bet you the angle has to be as small as possible. Small. That was meant to be an equal sign. As possible. That's what we need to do. So we need to find a way to calculate the angle between basically 3 points, I think. Yeah, that's what we need to do. So we'll give it 3 points. And we need to find the angle between these 2 points. Okay, so how do we do that? Well, that is a very good question. Okay, so let me see. Let's think of how we would do this normally. So we do page, new page before. And if we have a right triangle, right, something like this, we can just do the angle here is going to be 90 degrees. But this angle is going to be opposite over adjacent, or, you know, whatever. We can find it via standard trigonometric functions. Okay, but we're in a bit of a bind here, because how do I find the angle BAC? That's the question. How do we find, so if we have 3 arbitrary points in space, 1, 2, 3, how do we find this angle here or this angle here? Either angle will do. Well, we can of course draw it as a triangle, but for some reason I'm drawing a blank. Do trigonometric functions work for non-right angle, for non-right triangles? I'm gonna have to Google the most embarrassing thing ever for a physicist to Google. Trig functions. Non-right triangles. Let me see. Let's see. Law of cosines defines the adjacent. So let's see. Okay, that wasn't exactly what I wanted. Yeah, I totally forgot all of this. Okay, what do we have here? A over sine of A is equal to B over sine of B equals C over sine of C. Well, we have the distance between C and A. Oh, angle of A. We want the angle of B. Okay, so what we need then is, let me see. We have angle side, we have side angle side. That's what we have. Oh, I bet you there's totally a way to do this. Side angle side. There we go. Solving side angle side. Math is fun. Totally is. Okay. Angle is equal to 49. Let me see. What do we have here? Law of cosines. A squared cosine A. Yep, that's what I'm looking for. So then that means that if we follow this formula, which I'm going to write down over here, it's going to be A squared plus B squared equal plus C squared. Oh, what am I doing? A squared equals B squared plus C squared minus 2BC cosine A, and the triangle looks like, which one is B? Oh, okay, so it's A, B, C, and we have A up here, B over here, C over there. Okay, good. So let's go ahead and recreate this image, and let's see what we got. Sorry about that, guys. This is me not remembering high school geometry. My bad. Okay, so what we need then is the following. So we're going to have a triangle, something like this, and we're going to have it defined like this. So we'll have, how about A, B, C, and then we have A, B, C, and we have the following equation: A squared plus A squared equals B squared plus C squared minus 2BC cosine of A. But what we want is cosine of B up here. So this is going to be cosine of B. This has to be A, I bet. BC. AC. Yep. Okay. So now let's say B is going to be equal to A cosine of a squared plus b squared. Oh, I'm sorry. It has to be a squared minus b squared minus c squared over 2ac. That's what we're looking at here. So I'm going to write this down too, just to make sure I have it. Now, one thing that is kind of weird here, I feel like there's a way to do this without trigonometry. So b equals a cosine of a squared minus b squared minus c squared over 2ac. Okay, but now let's see, is there a way to do this without trigonometry? That's my question. For some reason I kind of feel like no matter what, we're going to need this. Because based on the gift wrapping algorithm I have, it seems like that angle is essential to understanding how to do the actual gift wrapping. So let's go ahead and write in the angle function, and then we'll kind of go from there. So let's see, what do we have? We have is the angle between 3 points. So let's go ahead and pop over here, and let's just create the angle function. So here what we're going to do is we're going to say, let's say finding the angle between 3 points. Let's go down here and let's say double angle, and it's going to be position A, position B, and position C. So we're going to have to create a couple distances. So let's go ahead and pop down here. Oh, actually, let's just put this function down below. Oh, it's fine. We'll define it up here. Whatever. Doesn't matter. So first, let's go ahead and define our distances. So we're going to say, and let's go ahead and just keep the notation the same. Let's change this to capital A, capital B, and capital C. Okay. Now we're going to say double A is going to be distance between B and C. Okay. We want double B equals distance between. If you have two vectors, you can always use a dot product equation to find stuff like this. One second, let me think. It is A dot B equals magnitude of A times the magnitude of B cosine of theta. But the issue here is that we're between 3 vectors. So let me see. Like if we had 2 vectors here, page, new page before. 1 second. We could do the following. Let me see. Maybe I'm overcomplicating this. So we had 2 vectors here, here and here, right? Oh, we do have 2 vectors. You're totally right. Yeah, we do have 2 vectors. So we can just say cosine of theta is going to equal to a cosine of, 1 second, a cosine of a dot b over a magnitude of a times the magnitude of b. Yeah, we can totally do that. Yeah, because we do have 2 vectors. I just have to subtract the 2 of them. Now let me think. There's one thing that I'm kind of worried about. Last time I did this, it didn't actually return the angle appropriately. I don't remember why. No, I do remember why. We were only getting first quadrant stuff. Yeah, I gotta think about this one. Okay, because I'm using my own position, I think I can just use, let me think. So in this case, I have to calculate the dot product and also the magnitude. Let me just go ahead and go on with what I was doing before, because I think it's less computation in the end, but not by that much. It really doesn't make that much of a difference. Okay, and we're gonna have to test it anyway. So we're gonna take distance between A and C, And then we want this one, which is going to be double C. It's going to be distance between A and B. Okay. So now what do I want to do? I want to say return. And this is going to be a cosine of, I guess, A times A. Let's go ahead and put it here. A times A minus B times B minus C times C divided by 2 times A times C. Yeah, you're totally right. I just didn't think about it at the time. I don't know why I always forget about the dot product thing. And here we go. But you're right. You're totally right. In essence, I should have used that. I just didn't think about it at the time. Okay, so this should return the angle. We're going to have to test to make sure it does. So let's go ahead and run that. Let's see. So we have A, B, and C. We can go ahead and write a test to make sure this works. But let me go ahead and put the structure down for everything else, and then we'll kind of go from there. So we have this angle here. And what we want to do now, since we already have the gift wrap thing here, let's see, for I in PowerPoint.size, J++. Let's just go ahead and write down what we have. And then let's put a note that this needs to be tested. So let's go up here and put a note down there. Here we are. Notes. Test. What do I want? Angle. Function. Okay, there we go. Okay, so what do we have here? We have the current hole. And we also have the next hole that we're working on. So let me think. What do we have here? I suppose the 3 points that we're going to want to read in are going to be the hole. Oh, I think we're going to have to do something special here. Yeah, I think we're going to have to do something special. Okay, so let me think. So for the initial point, let me go back over here to the Wikipedia article real quick. Where are we? Here we are. For the initial point, they kind of look at it from, let's see, a position of, I guess, 0, 0, maybe? Yeah, I guess the position doesn't really matter here, right? I mean, no matter where we have the previous point. Yeah, so I guess the other position doesn't really matter that much. In fact, let me see something. I guess it doesn't really matter where we measure the other angle from. Does it? Let me think. So if we're measuring our angles here, let me just go ahead and draw this image up. Okay. So here we have this angle there, right? So that's going to be those little circles that we have there. And the idea is that we minimize that angle, right? Okay. So we do have to measure an angle. I think I'm convinced that we need to measure an angle. However, I'm not convinced that we need the previous point. I suppose we do need another vector, but I think that vector can come from anywhere. So we can just use the point itself as the vector, and then we could use the dot product relation. Or we could just read it always from 0, and that's fine too. Because no matter where that other point is, does this make sense, guys? What I'm saying is, it doesn't matter where this previous point was, right? So I guess what I'll do here is I'll just go ahead and define up here what I want. I want position current hole, and then I also want, I guess, previous hole. Why not? Yeah, it doesn't really matter that much. So let's go down here and let's say previous hole dot x equals 0.0. If I can do anything right, it's not this. Paste and do dot y2. Okay, good. That'll be fine for now. Okay, so we have the current hole is equal to part hole. There we go. So we went ahead and initialized it there. Now let's just go ahead and do the rest of the algorithm. So what we need to do is first find the angle. So we're going to say we want to do angle equals. Oh crap! I don't have the angle. Oh my gosh. Okay. So let's go up here and let's define the angle too. The angle is just going to be a double. So let's go ahead and put it here. Angle. Let's pop down here and let's say if, let's set it equal to 0 to start. Oh, how about equal to 2 times pi? I think it's m pi. Man, I'm moving really slowly today. I'm sorry, guys. So what we're going to say is if, and I guess we're also going to do a temp angle. Something like this. I'm sorry. Temp angle is going to be equal to, oh my gosh, this is awful. I'm sorry about this, guys. Is going to be equal to angle between, oh crap, I can't define it as angle. Screw it. Screw it. Let's do angle temp. Oh, what am I doing? Oh my gosh. Everything is wrong. Angle temp is going to be equal to angle between the 3 points that we're working with. So this is going to be previous hole. Then it's going to be current hole. And then it's going to be the next point, which is going to be, what do I have here? Par dot points of j. Okay? There we go. So now we have the angle temp. And what we're going to say is if, would it? I don't know. I think it's about the same. Yeah, we'll see. So let's do, I don't know. We can read in the vector library later. I mean, it's basically the same. I mean, I don't think it really changes the readability here because we're not going to be using any of the vector library stuff. But yeah, I can add it in tomorrow. I guess it's going to be a 2-day simulation. Sorry about that. I didn't mean for it to be 2 days. I thought it was going to be a quick 1-day thing, but whatever. So now what we need to say is if angle temp is less than final angle. And let's see, what do I have here? Let's go ahead and read in final angle. Equals 2 times mpi. Hey, Gothic Death Eater, what's up? So let's go down here and let's see. What do we have here? Let's just do final angle here. I clearly did not prepare this well enough, but that's okay. I mentioned at the start of stream why we're doing this right now. So let's go ahead and do final angle equals 2 times mpi. There we go. And if angle temp is less than final angle, we are going to say equals final angle temp, and then I want to say let's see, current hole, dang it, next hole maybe is going to be equal to what do I want here? I want par dot points of j. Okay, so now we're gonna have to create a next hole because I am doing this really sillily. Okay, there we go. Something like this. And then at the end here, we have the final angle there. Angle text next hole. And then after we have this for loop, we're gonna pop down here and we're going to say, 1 second, it will be, what is it gonna be? It will be, see, current hole, previous hole. I'm going to say par dot hole dot pushback, and I'm going to say next hole. And there's one last thing I need to do, which is set previous hole equals next hole. No, that's not what I need. Final angle next hole. 1 second, current hole. And then I guess current hole equals next hole. Something like this. Ah, man, I could do this way easier. I could actually remove current hole entirely. Yeah, I could remove current hole entirely from this simulation. Yeah, I totally could. Just by having I equals 0. If I equals 0. So what if we do this instead? So let's do a I++. And instead of having current hole in here, what we're going to say is the distance between, let me see. Yeah, there's totally a way to remove I plus I from this, or remove the current hole from the simulation. But let's kind of look at that tomorrow. So I'm going to go put this up into notes because we are kind of running out of time for the day. Let's pop down here and let's say remove or fix up. Yeah, that's totally true. So let's do fix the, what do I want to do here? Gift wrapping syntax. Okay, so again, as mentioned, this right here is the easiest and most, or the simplest gift wrapping algorithm. But there's a whole bunch of others out there. I kind of wanted to just spend some time working on this just because I thought it was kind of interesting. As I see, you want to use SC cosine if you include CMath. I just see if you want, let's see what happens. Let me just very quickly write this, compile it, get it to compile, and then we're just going to kind of leave it. Next hole, not defined, so let's go to 110. If that's the only problem I have in this code so far after screwing around for the past 10 minutes, okay, well, okay, so it compiles. Totally compiles. We're going to have to test this out. So a couple of notes here. First of all, this is the most, it's like the simplest gift wrapping algorithm out there. It's a convex hole problem, right? So the idea is that you're trying to find the outside of this list of points. So in many senses, this can be improved on, and it definitely can. So we can show ways that it can be improved on later, but for now, this will be kind of okay to start with. I just kind of want to test it out, and I kind of want to work on it from there. Because it's called the gift wrapping algorithm, I thought it'd be kind of nice to just make a very quick, how do I put this? To make a very quick, what does including CMath do here? I think it's okay. Well, what's the difference? Why should I include? Okay, I'll include CMath, sure. Okay. Anyway, point is, this is not the fastest algorithm. There are faster algorithms out there, and we will probably take a look at other faster algorithms in a bit. But for now, I just kind of want to do the gift wrapping algorithm, get this written, and then work on other convex hole problems after that. I'm kind of interested in a couple of different applications of the convex hole problem, and I'd really like to look into it in the future. Anyway, guys, that is it for the day. What I'm going to do, since this is compiling, I'm just going to go ahead and very quickly commit it to GitHub. I realize that's probably very bad practice, but hey, everything about my GitHub is bad practice. So let's do git add jarvis.cpp. Let's do git commit jarvis.cpp message, adding skeleton for gift wrapping algorithm. Okay, there we go. Adding skeleton. Sure, that'll do. Good. So now we're gonna do git push origin master. I know you guys should have access to it on github.com. Okay, anyway, guys, that is about it for the day. I realized we didn't get quite as far as I would have liked, but, you know, we're getting there. So we have a couple different algorithms to kind of look at. The fastest gift wrapping algorithm so far as I can see, and by gift wrapping, I mean convex hole problem, is the Chan's algorithm, which is something that I do want to look into, and we'll see how far it takes, or how long it takes to get there. Other things I want to look into, I want to kind of visualize this just because I think it's quite interesting, but that won't take so long. I think we're basically set there as far as visualization is concerned. Anyway, guys, thanks so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time, and I will see you around next time for the next episode of Simulaos. As always, I will be kind of in and out of the Discord server that I will put right here, if I can spell Discord, and feel free to check in there if you're interested. And that's about it. So guys, have a great day. I'll see you around. Bye, guys.